Section 6.3, double angle and half angle formulas. There are many applications in science and engineering that's related to light and sound for double angles and half angles. Doubling sine will not give you the value of sine of 2x. Nor would taking half a sine give you sine of x divided by 2. Okay? And if you want to know, here's one of them that I am deriving. It will show you how to derive it. If we take the sine of 2x, remember the sine of x plus x, the formula? There's the formula for it. Sine of alpha plus beta is equal to sine of alpha, cosine of beta, sine of beta, cosine of alpha. When you plug in here, you have 2 sine of x, cosine of x. So sine of 2x is equal to 2 sine of x, cosine of x. So there's one of them. Similarly, you can do the same thing for cosine of 2x and tangent of 2x. There are the formulas. I would have these formulas in front of you when you are doing your homework. And you have to memorize the double angle formulas. The half angle formulas I will give you on a test. So I will give you the half angle formulas. Double angle, I want you to memorize. I wrote the tangent half angle formula as different formulas. It's equal to this, or you could do some algebra with it. It's equal to there, or there. So it's equal to different things when you do algebra on it. The reason all these have a plus or minus in front of it is because you have to look at where is the alpha minus 2. Which quadrant is it in? And based on the quadrant it is in, if alpha minus 2 is in the first or second quadrant, that would be positive. If it's in the third or fourth, it would be negative. Cosine of alpha over 2, look at what quadrant that's in. If it's in first or fourth, positive. Second or third, negative. Tangent, it'll be positive if it's in the first or third, negative if it's in the second or fourth. So that's why there's a plus or minus in front of all those. Okay? So let's go to the next for some examples. Given that cosine of alpha is equal to negative 5 over 13, and I'm in the first or third quadrant, I want to find the sine of 2x, cosine of 2x, sine of 3x, and tangent of 2x. Remember your formulas right there. Remember that. There's my formula. So the sine of 2 alpha is equal to 2 sine of alpha, cosine of alpha. So when I'm drawing these, I would probably draw them out first before I plugged into the formulas. Remember, I'm in quadrant 3, and cosine 5, 13, so that's 12. So there's my picture. So I have 2 sine of the angle. Sine of my angle is the opposite over hypotenuse, so it's negative 12 over 13. Cosine is negative 5 over 13. A negative times a negative is a positive. 5 times 12 times 2 is 120 over 169. And you're done with that one. Cosine of 2 alpha, there's your formula there. Or there. Or there. So I don't care which one you use. You can use any of these 3. You can use this, or you could use that, or you could use that. It does not matter. You get the same answer. I am using 2 times the cosine of alpha squared minus 1. But I didn't have to. I'm using the last one. So 2 times negative 5/13 quantity squared minus 1. 5/13 quantity squared is 25 over 169. Times 2 is 50 over 169. Minus 1 I can call 169 over 169. 50 minus 169 is negative 119 over 169. And so there's sine of 2 theta, cosine of 2 theta. Now, sine of 3 theta. Well, remember sine of alpha plus beta, what that's equal to. Well, instead of alpha plus beta, I could call it theta and 2 theta. So I could use the formula sine of theta, cosine of 2 theta, plus sine of 2 theta, cosine of theta. I already know what sine of 2 theta and cosine of 2 theta are, so I just plug them in. And you also know what sine is and cosine, so plug in everything you know. So My sine is negative 12 over 13. My cosine of 2 theta is negative 119 over 169, plus, there's my sine of 2 theta, 120 over 169, times the cosine of theta. Cosine is negative 5/13. And when you do the math, and I'd probably get my calculator out to do that, 12 times 119 gives you 1,428. 13 times 169 gives you 2,197. A negative times a negative gives you a positive. And this ends up to be minus 120 times 5 is 600. The same denominator. 1428 minus 600 is 828 over, whoops, not 24, 2197. And you're done. Okay? Next example. Or no, we're not done, we're done with everything. I want a tangent of 2 theta too. Forgot about that. Different ways to find tangent of 2 theta. The easiest way probably is just to do sine over cosine. And sine is 120 over 169. Cosine is negative 119 over 169. So I probably would do that, even though I might have done it differently here. I might have used the formulas here. I don't know if I did or didn't. Yes, it looks like I did. But let me show you using the formula. You'll get the same thing. And you don't need to write any of this down if you just remember. This is a long way to do it. Okay? And the short way to do it is remember that the sine of 2 theta over the cosine of 2 theta is tangent of 2 theta. Sine is 120 over 169. Cosine, negative 119 over 169. The 169s cancel, and I have 120 over 119, and it's negative. That's the fast way to do it. And that's probably how I would do it. I probably wouldn't use the formula, since I already did the sine and cosine of 2 theta. Next one. Find the exact value of 2 tangent of 75 over 1 minus tangent squared of 75. Well, remember the formula. 2 tangent of 75 over 1 minus tangent squared of 75. My alpha is 75. So this is equal to tangent of 2 times 75. 2 times 75 is 150. So this is tangent of 150. And when you're doing 150, 150 is in the second quadrant with a 30-degree reference angle. 1, 2, radical 3 are the sides. Tangent is opposite over adjacent. I wrote negative tangent 30, but it's opposite over adjacent. You don't have to write it that way. Negative 1 over radical 3. Get the radical out of the bottom, and it's negative radical 3 over 3. And you're done. Let's do another example. Example 3, use half-angle formulas, find the exact value of sine of pi over 8. There's a formula written. Remember your half-angle formula. You can think of alpha over 2. I want something over 2 to equal pi over 8. So is there a triangle that you know, the pi over 6s or pi over 3s or pi over 4s, where half of it is pi over 8? And I hope right away you know that it's pi over 4 divided by 2. So your alpha is pi over 4. Pi over 4 divided by 2 is pi over 8. So alpha is pi over 4. And pi over 8 is in the first quadrant, so that is positive. So I have positive 1 minus the cosine of pi over 4. A pi over 4 triangle is 1, 1, radical 2. So the cosine is 1 over radical 2, or radical 2 over 2. I don't really care which way you write it. So that's what I have next. And then now let's neaten up the fractions within fractions. I can rewrite 1 as 2 over 2 to get a common denominator. And then the numerator, I wrote it here, but let me show you how I got that. There's my numerator, here's my denominator. Numerator divided by denominator is the same thing as numerator times the reciprocal of the denominator. So that's how I got the 4 on the bottom. Okay. And then you can take the 4 out of the radical, because you can think of this as radical over a radical. Radical force 2. And you're done. Next example, half angle formulas. 112.5. If you double 112.5, you get 225. So I can call this the cosine of 225 over 2. That is 112.5. And so now this is 1 plus the cosine of 225 over 2. 225 is in the third quadrant. That's 225. This is 180 to 225. That reference angle is 45 degrees. So it's a 1, 1 radical 2 triangle. Okay? So there's your picture. Let me draw a better picture of it. 1, 1, they're both negatives, radical 2. Okay, so that's what I have there. 112 degrees. That's what this positive negative is. 112 degrees puts me in this quadrant. 112.5 degrees. In the second quadrant, cosine's negative. So that's why there's a negative in front of there. So now 1 plus the cosine of 225 degrees. 225 degrees, cosine is negative 1 over radical 2. So let's plug that in. And now I'm going to simplify it. I'm going to call 2 over 2. And it's the same as you did before. 2 minus radical 2 over 2, all over 2 would be all over 4. And then you take the square root of that. The rest of it written. So this is just, the end of it is just like the last problem. Next one, cotangent is 3 over 4, and it's in the third quadrant. Find the exact values of sine of theta over 2, cosine of theta over 2, tangent of theta over 2. Okay, so my angle theta is somewhere in the third quadrant. And cotangent is adjacent over the opposite. Or yes, adjacent over opposite. So my hypotenuse is 5. Okay? So there's my picture. So that's theta. This is theta. From here to here is theta. It's the angle theta. So the angle theta over 2 would put me somewhere in the second quadrant. So in the second quadrant, this would equal a positive. In the second quadrant, that would equal a negative. In the second quadrant, tangent would also be negative. Okay, so now I have my signs of them. Like I said, second quadrant, positive. Second quadrant, negative. Second quadrant, negative. Because that alpha over 2 is in the second quadrant. Or theta over 2 is in the second quadrant if theta is in the third quadrant. So there are my formulas. Now all you're really doing is plugging in. Because you know cosine is negative 3 over 5. Yeah, that's all you need, cosine. this. Cosine is negative 3 over 5 through my picture. So the sine of theta over 2. There's my formula. So I have 1 minus a negative 3 over 5, which becomes positive. 1 I can write as 5 over 5, so 5 over 5 plus 3 over 5 is 8 over 5 over 2. Numerator divided by denominator is numerator times the reciprocal of the denominator, so it's 8 over 10, or 4 over 5, you can reduce it, or radical 4 is 2, radical 5 is just radical 5, and then get the radical out of the bottom. You have 2 radical 5 over 5, and you're done. Let's do the same thing for cosine. There's my formula again, and I said it was negative. So I have 1 minus or plus a negative 3/5 over 2. 5 over 5 minus 3 over 5 is 2 over 5 divided by 2, which gives me 2 over 10, which is 1 over 5. Radical 1 is 1. Radical 5 is radical 5 in the bottom. Radical 5 over radical 5 gives me radical 5 over 5. Tangent, the last one. There's your formula again written. So I have 1, it's a negative. 1 minus a negative 3/5 would be plus 3/5 over 1 plus a negative 3/5 would be 1 minus 3/5. So 5/5 would give me 8/5. 5/5 minus 2/5 would give me 2/5. Numerator divided by denominator is numerator times the reciprocal of the denominator. So it gives me 8 over, oh, there it is, the math, gives me 8 over 2, or 4, radical 4, which is 2. And the negative is in front, so it's negative 2. And that's example 5. Example 6. Example 6 is, I want to solve sine of x minus cosine of 2x is equal to 0 for the interval from 0 to 2 pi. So let's solve that. Well, what do I know? I know a formula there. So I could probably plug in that formula for cosine of 2x. I could plug in 1 minus 2 sine squared of theta. There were other formulas that you could have used, but this one, the reason I chose this one was then I'd have all sines here, and maybe I could factor it, okay? So I have sine of x minus what I'm plugging in, which is 1 minus 2 sine squared of x. And then I'm going to rearrange it. Oh, and it's equal to 0. I'm going to rearrange it. I'm going to factor this. So I would put down 2 sets of parentheses. Where my 2 sets of parentheses are. And then know that my first terms will have to be 2 of sine x and sine x. So there are my first terms. My last terms have to be a 1 and a 1. One of them that will be a negative. But remember, when I add the inner and outer, I have to get a positive. So there's my positive 1 and there's my negative 1. Now, do you remember with factoring, the only way to get 0 is if 2 sine of x minus 1 is equal to 0, or sine of x plus 1 is equal to 0. So I'm going to solve 2 sine of x minus 1 is equal to 0, and I'll get sine of x is equal to half. Solve sine of x plus 1 equals 0, move the 1 over, get negative 1. I have them written down somewhere. Here's the other one. Right there for some. Okay, so those are the 2 I have there. And to solve that, I'm solving it from 0 to 2 pi. Sine of x is a half, 1/2. I hope you know that's a 30-degree angle. And I could be in the first quadrant, or I could be in the second quadrant with a reference angle of 30 degrees. So that's 30 degrees or 150 degrees. Or in radians, it's pi/6 or reference angle of 30 degrees or pi/6. And I'm in the first and second, which I said, quadrants. So I'm pi/6 in the first quadrant, and the second quadrant I'm at pi minus pi/6, which is pi/6. And I'm done. For sine of x is equal to 1, remember sine is y/r. Y is -1 at one of the quadrantal points. And I hope you know that it's at 3 pi/2 down at the bottom. When you're doing these quadrantal points, it's down here. Okay? So x is, that's the only place. 3 pi/2, x, sine of x is equal to -1. And we're done.